So let's take a look at the other part of a specific right triangle relationship that's unique to trig, and that's a 45-45 triangle, or what the book will call an isosceles right triangle. Okay, so in an isosceles right triangle, we know that these two angles are equal to each other, so they have to be 45. We also know that the legs are equal. So this, whatever it is, it could be 1, it could be 2. I'm going to make it 1 for the sake of being easy to deal with. So if we wanted to find this missing hypotenuse, so I'm just going to call it r, we're going to get 2 equals r squared. R is going to be the square root of 2. The hypotenuse, in this case, is larger than the legs by a factor of the square root of 2. So if these had been 2 and 2, it would have been 2 square root 2. So if I find the 6 ratios, I'm just going to do this from a problem, 315 degrees. If I go around, that's in quadrant 4. Coincidentally, it doesn't matter what I do, that would be a 45-degree angle right here. So what I really need to do is I need to figure out what the ratios are of a 45-degree angle. I'll deal with the signs later. So what I need is the fact that these two are the same. This is a square root of 2. Well, since I'm in quadrant 4, this has got to be negative. So if I evaluate this, I get that the sine of 315 degrees, opposite over hypotenuse, is negative 1 over the square root of 2, which is negative square root 2 over 2. So when we talk about 45 degrees, and I can just write this up here, 45 is the exact same thing except no negative. How about cosine? Well, cosine is 1 over the square root of 2. So it's the square root of 2 over 2. So the cosine of 45 degrees is the exact same thing as the cosine of 315 degrees. How about tangent? That's going to be negative 1 over 1, which is negative 1. So the tangent of 45 degrees is 1. Cosecant is hypotenuse over opposite, which is the square root of 2 over negative 1, which is negative square root 2. So the cosecant of 45 degrees is exactly the same minus the negative sign. So the cosecant is the square root of 2. The secant of 315 degrees is the same as the cosecant of 45 degrees. So we have the square root of 2 over 1 reduces to the square root of 2. So the secant of 45 degrees is equal to the square root of 2. Finally, the cotangent of 315 degrees is negative 1, or the adjacent over the opposite. So the cotangent of 45 degrees is just 1. So those are my 6 ratios for 45 degrees, and it's the same for any quadrant you're in. You just have to worry about the signs. In this case, cotangent and sine, tangent and cosecant are all negative. So what you have to worry about is when you deal with things that are in different quadrants and you're asked to square them. This is like saying, well, sine of 225 degrees, that's in this quadrant, but really it's 180 plus another 45. So it's like saying, I want to take the sine of 45 degrees in quadrant 3. If you view the picture right. Well, the sine of 45 degrees is the square root of 2 over 2. So I got to square that. The square root of 2 times the square root of 2 is 2 over 4. Now I got to do the exact same thing with this one. The cosine squared of 225 degrees is like saying I want the cosine of 45 degrees in quadrant 3. Well, the cosine is exactly the same thing. So I'm taking 2/4 or a half plus another 2/4 or another half, and I get 1. Cosine squared of 60. Well, from what we did, a 60-degree angle, if this was 60, this is what our picture looked like. 60 degrees cosine was 1/2, so 1/2 squared. 30, well, that was a 30-degree angle up here, so sine, that's 1/2 squared as well. So I get 1/4 plus 1/4 is equal to 1/2. So what I'll talk about in class is this last problem.